Hi, sixth grade. This is the first video for our Measuring Matter unit, and we've been talking a lot about our problem, which is what's the best measurement or what's the best way to measure our ingredients for our pancake recipe. And so we kind of came up with that there's probably three different measurements that we could look at: weight, mass, and volume. And we said that for like foodies and chefs, that their big argument is it better to measure our ingredients by weight, or is it better to measure them by volume? And we decided to kind of throw mass in there because mass is what scientists, we hear them use mass all the time. So, but our big discussion really was we kind of put weight and mass together. And we said that we remember talking about in fifth grade, that weight and mass might not be the same thing, but we confuse them a lot. We said that we feel like chefs might be using the term weight and scientists might be using the term mass. So we're really going to take a look at today in this presentation, mass versus weight. We're going to hold off on volume for a little bit later. And so looking at mass and weight, some of you are like, okay, I think I know what weight is measuring, but I have no idea what mass is measuring. Is it measuring the same thing, something different? So let's just kind of take a look at that. So looking at mass, because that's kind of our newer, well, let's look at weight first, because you guys, a lot of you could tell me that weight is actually measuring the pull of gravity on an object. So I kind of always think about here with weight, if a memory trick to remember my definition is that I turn these into like downward pointing arrows because it's all about that pull. So if I was to have a football here and I hold it, I'm going to drop it, it drops down to, eventually it would keep dropping if there was nothing in its way, to the surface of Earth. And that's because Earth's gravity is pulling it down towards the surface. So really weight is actually measuring gravity. Okay, we're looking at this purely scientifically. Mass is actually measuring how much matter is in an object. And we know that matter is made up of what? Atoms and molecules. Okay, so if I take a look at this cube here, and we are trying to figure out the mass of it, we would actually be measuring how much matter is making up the cube. So I have a picture here so that you can see, it's taking into account all of those atoms making up the object. And so mass is measuring matter. How I like to remember the definition for that is that mass starts with M, matter starts with M, measure starts with M. So mass measures matter. It makes a really good alliteration. My favorite candy is also M&Ms. And so I like to think M and M, mass, matter. So in your ICANN statements, the first thing was we need to figure out what these two things were actually measuring. And so let's take a moment to add these over into our notes. So this is a new unit, so I've created a new document. If you're typing it, you are more than welcome to create a new document and title it Measuring Matter. If you like all of your notes in one document, just keep going. If you're handwriting, just move on to the next page. Up at the top, I'm going to title it Measuring Matter Unit. And then we're really going to be kind of looking at mass and weight right next to each other and kind of contrasting them and seeing how they're different. And so I think for our notes this time, it might be good to set it up as a table. And so then I'm going to put mass and weight in the center. So I'm going to do my center align button. I'm going to put mass. I'm going to put my center align button over here. I'm going to put weight. And then on my next line, I'm going to take it back to the left align. And I'm going to use bullet points. You guys know I love using my bullet points. And so our definition for mass was it's a measurement. So the measurement of the amount of matter in an object. And then for weight, I'm going to left align again, bullet point, weight is the measurement of the pull of gravity on an object. Now, looking over here, we really kind of want to talk about what scientists prefer to use to measure. Scientists actually will measure everything in mass. They don't like to use weight. So if we think about that, that is because weight really kind of deals with location. Now, for humans, we are majority of the time, and chefs specifically, they are always on Earth. They're not going to be studying matter anywhere else in the universe. They're not going to be baking anywhere else in the universe. Now, for our scientists, though, if they're an astronaut, they actually might have to be baking on the International Space Station. So I'm going to kind of jump over here, show you guys a picture of our International Space Station. So this is actually orbiting the Earth right now. And if you're an astronaut having to bake up in the International Space Station, something might be very different for you up there. Do you guys remember what's different about up in the International Space Station? We watched a video with some astronauts up there earlier in the year. It's actually that there's no gravity. So if we were looking at baking, let's say we're going to be baking our pancakes, and we want to make a recipe where we want to be able to bake anywhere in the universe. We're really going to have to think about what that would mean if we measured our ingredients according to weight, or if we measured our ingredients according to mass. Now, if we go back a slide, what we're actually measuring when we're looking at weight is the pull of gravity. What we're looking at when we're measuring mass is how much matter is in an object. So if we think about maybe just like a bowl full of sugar. When I have that bowl full of sugar at school, it's going to have the same amount of matter. What about when I take that bowl of sugar home to bake a cupcake or a pancake? Same amount of matter. If I take that bowl of sugar out to the International Space Station, out in space, will I still have the same amount of matter? Yes, we haven't changed the amount of sugar, so it's still going to be made up of the same amount of atoms and molecules that it was at my house and that it was at school. So this measurement isn't going to be changing no matter where we're at in the universe. Now, if I think about weight, weight isn't measuring matter. Weight is actually measuring gravity. So if I take my bowl of sugar and I have it here at school, and I was to hold my bowl of sugar up and drop it, it would fall. Okay, fall at the same amount of weight. There's gravity here. If I was to take my bowl of sugar home and drop it, the bowl would still drop. Same amount of gravity here. Now, if I was to take my bowl of sugar to the International Space Station up in space and drop it, it would actually float. That's the issue with weight. In our everyday life, so as a chef, they are never going to leave Earth. So to them, weight and mass are the same thing because gravity never changes for them. But if we're actually going to be looking at a true measurement as a scientist state of mind, and we want to write a recipe for somebody that even like an astronaut could use up in space, weight probably wouldn't be the best to use because weight is truly measuring gravity and not matter. And we know that sugar is an example of matter. So we really want to be focusing on using mass. So if we kind of take this and look at maybe our astronauts land on the moon, okay? So we have 120 kilograms worth of sugar with our astronaut on Earth. When the astronaut takes that sugar to the moon, are we adding any matter to it? Nope. So we're still on the moon going to have 120 kilograms of sugar. Now remember, weight is actually measuring gravity. So if we have 1,200 newtons, that's actually how we would calculate the weight. See how they're not going to be the same number? We take the mass of our sugar and multiply it by what our gravity is, because weight measures gravity. We would actually have 1,200 newtons worth of sugar on Earth. If we were to take that same 120 kilograms of sugar to the moon, we would actually only have 200 newtons worth of sugar there. So our rate for our measurement is actually going to change. So in writing a recipe, we want to use mass because mass is measuring the matter. Weight is measuring the gravity. So then I wanted to kind of phrase this question to you here now. What about if we were to take our astronaut and take it to the International Space Station? Kind of talked about this already. I just want to make sure that you have it down in your mind. If we have 120 kilograms of sugar right out here in the middle of space, would we still have 120 kilograms of sugar in space, taking it from Earth to here? For our mass, would our mass change? No, our mass wouldn't change because we're not adding or taking away any matter. Now, what if I said that you needed 1,200 newtons of sugar out in space? We wouldn't get 120 newtons because there's no gravity in space. So we would actually have zero. Our weight would be zero out in space. So I know that this is a little bit confusing. So if you're still struggling with this concept, make sure that you talk to me. But what we really want to see here is that mass doesn't change based on location. It's going to stay the same because mass measures matter. Weight, on the other hand, is going to change based on your location in the universe. So let's just kind of get that fact written down into our notes. So mass will not change based on location. So if we have on Earth 120 kilograms of sugar, on the moon we're going to have 120 kilograms of sugar, and in space we're going to have 120 kilograms of sugar. I'm just going to tab these over because these are kind of examples supporting that. Weight, though, will change based on location because gravity is changing, and we're actually measuring gravity. We're not even measuring the matter. So on Earth, we might have 1,200 newtons worth of sugar. Even though we're changing nothing about the sugar, nothing at all, on the moon, because there's less gravity, it would be 200 newtons. And in space, weight would be zero because there's no gravity. So what we're really doing is we're finding out that weight has nothing to do with matter. Weight has everything to do with gravity. And so we really want to focus on mass as a very good measurement because our mass isn't going to change unless we change the amount of matter in the object. Now, we've been kind of talking units here already, and this isn't going to be something that I'm going to test you on, but you are going to see units popping up a lot in our conversations, and you're going to have to use those units properly when you are finding your measurements. So the units that we're using for mass would be kilogram, and that would be for something large. So if we had 120 kilograms of sugar, it would probably be maybe like half of a bag of sugar. Or I'm sorry, 120 kilograms of sugar, that would be a huge amount of sugar. Okay, if you think about a bag of sugar that you get in the grocery store, a bag of sugar at like Walmart is about like probably close to 2 kilograms. Okay, so if we were talking about 120 kilograms of sugar, that's a lot of sugar. For something that's small, we would want to use grams. So for our recipe, we're probably going to be measuring our sugar out in grams. For weight, you can see that they're using the Newton, and that kind of goes to recognize Sir Isaac Newton. I'm sure you've heard of this scientist. He was one that first started thinking about gravity and what gravity actually was. So they're just trying to give him a little bit of recognition for discovering gravity in the first place, and that's why we use his last name as a unit for weight. So even though we're not going to be tested over this, I do want to put this in your note because it is going to be kind of important. So units for large items is the kilogram. Units for small items is the gram. We'll put the abbreviation. I'll spell out the full word for you there too. And then our unit for weight is the Newton. Now, we were talking about the different types of tools that we might need to use on our, we'll come back to that slide. You might need to talk about the tools that we're going to have to use in order to measure. And a lot of you said that we should be measuring mass and weight with a scale. Actually, we're only going to use a spring scale for weight. So we've already kind of determined that we don't want to measure anything for our ingredients with weight, so we're not even going to worry about the scales. What we're really going to worry about is mass. And so the tool that we use to measure mass is a balance. And there's a whole bunch of different examples of different types of balances that we can use. These are ones that you might see at the doctor's office. You might see these are different types of balances here. And then this is going to be what we use. We're going to use a triple beam balance. Eventually, after you prove to me that you can use a triple beam balance, I'll let you use the digital balance, where you just get to set it on there and it gives you the reading digitally. But this is really going to be our next goal and our next activity, is how to use this item right here. The triple beam balance gets its name because it has 1, 2, 3 beams, and then we're trying to balance the masses over here. We call them riders. We're going to try to balance their mass with the mass of the object that we sit over here on the pan. And if we get it balanced, then I don't want to give away too much for you guys because you have to kind of figure out how to use the triple beam balance. But if it's balanced, we'll see that this little line here actually lines up in the 0. So that's why we call it a triple beam balance. We're trying to balance two masses against one another. And that's really easily shown here. So we might put something, an object in here that we know that has a mass of 100 grams. And then we'll put an unknown mass over here and we'll see if they can balance out or not, or if one has more mass, or if it has less mass. So in our notes, it's important we needed to know what that tool was called that we're using to measure mass. And so the tool that we're using is called a balance. And specifically for us, we're going to use the triple beam balance. And then I'm not even going to put down the tool that we use to measure weight, because like I said, we've just kind of figured out that weight wouldn't be a good way to measure mass, because or to measure matter, because we're going to go scientific, and weight is not a scientific measurement for matter. So just to kind of like end this video for you guys and to give you just really hone in why we want to use mass versus weight, you can kind of see how your weight would change on other planets. So there's a link on Google Classroom that you can visit. And you can see, you'll enter your weight here. So if you're like 100 pounds, you would enter 100. Then you'll press calculate. And then it'll show you what you would actually weigh on all of these other planets. Or if you want to think about like a cup of sugar, okay? So 1 cup of sugar, you could put like, is going to actually only weigh 0.44 pounds. So if we put that in there, then you could actually see how the weight would change for our cup of sugar on other planets, which it's going to be difficult to measure out a cup of sugar on the moon because it's saying that the weight would be 0. So you guys can mess around here. If you want kind of a different version of the difference between mass and weight, you can go ahead and read this as well. And it kind of gives you a little bit of more information. It tells you a little bit about Sir Isaac Newton as well. So that's there for you. Like I said, the link is on Google Classroom, so you can check that out. But other than that, heading back to our notes, this is the final set of notes that you should have here, and what you really kind of need to be taking away. Remember, we need to know definitions for mass and weight. We need to know our tool that we're using to measure mass. And then we need to know, how does mass and weight change based on location? Because that's really why scientists are choosing why we should be using the word mass as opposed to weight when we're doing our final experiment on the best way to measure ingredients. So we could actually kind of cross off one of our measurements now, and it kind of takes us down to 2. So if you have any questions or if you are confused by this, please make sure that you get with me for a conference, and we can get everything sorted out. So thanks for watching.